Entire continents buried beneath kilometers of ice. Seas frozen solid. Life struggling to survive on a planet transformed into a frozen world. For most of Earth's history, the climate hasn't been as stable as it feels today. In fact, we are currently living in a brief warm interval, a pause, between vast stretches of global ice. We call these periods ice ages. And the question scientists are now asking is chillingly simple: could it happen again? An ice age isn't a single frozen moment in time. It's a long period, millions of years, during which ice sheets exist on Earth's surface, expanding and retreating in rhythm with our planet's natural cycles. Right now, believe it or not, we are still in an ice age, the Quaternary Ice Age, which began around 2.6 million years ago. What we call our modern climate, the warm, green Earth we know, is actually just a brief interglacial period within it. When these interglacial periods end, the ice returns. Glaciers grow. Sea levels drop by over 100 meters. And much of the northern hemisphere becomes unrecognizable. The last time the ice truly ruled was about 20,000 years ago, during what we call the last glacial maximum. Back then, ice sheets more than 3 kilometers thick covered Canada, the northern United States, Scandinavia, and large parts of Europe. Sea levels were about 120 meters lower than today. You could have walked from England to France, or from Siberia to Alaska, across land bridges that no longer exist. This was the world of mammoths, woolly rhinos, and saber-toothed cats. And it was the world in which our own species struggled to survive. For tens of thousands of years, humans lived on the edge, following the ice, hunting the herds, clinging to warmth wherever they could find it. Then, something changed. Around 11,700 years ago, the last ice age came to an abrupt end. The planet warmed, fast. In just a few centuries, vast ice sheets collapsed. Meltwater flooded the oceans, drowning ancient coastlines. Temperatures rose by up to 7 degrees Celsius in some regions. This sudden shift gave birth to the world we live in today, the Holocene, a rare period of warmth and stability. For the first time, humanity could settle, farm, and build civilizations. Everything we know, from writing to cities to spaceflight, has happened during this single, fleeting warm spell. But the ice never truly disappeared. It's still here, sleeping, waiting, in Greenland, in Antarctica, in the frozen heart of the poles. So why do ice ages happen at all? What force is powerful enough to freeze an entire planet? The answer lies in Earth's orbit, and a man named Milutin Milankovitch, a Serbian mathematician from the early 20th century. He discovered that Earth doesn't orbit the Sun in a perfect circle or a stable tilt. Instead, our orbit wobbles, stretches, and tilts in long, predictable cycles, known as the Milankovitch cycles. Eccentricity: every 100,000 years, Earth's orbit changes shape, from round to more oval. Obliquity: every 41,000 years, the planet's tilt shifts slightly, altering the intensity of seasons. Precession: over 26,000 years, Earth's axis slowly wobbles, changing which hemisphere faces the Sun at different times. Together, these cycles change how much sunlight reaches each part of the planet, sometimes just a few % difference, but enough to tip the balance between ice and warmth. When sunlight decreases in the northern hemisphere, snow survives the summer. Ice accumulates. More sunlight is reflected into space. And the world begins to freeze. By Milankovich's calculations, Earth should be slowly cooling right now. Under natural conditions, the next ice age might have begun in about 50,000 years. But we've changed the equation. In the last 200 years, humans have added vast amounts of carbon dioxide and methane to the atmosphere, gases that trap heat. Instead of cooling, the planet is warming at a speed unprecedented in geological history. So, could another ice age still happen? Not anytime soon. In fact, research suggests that even if human civilization vanished tomorrow, the greenhouse gases we've already released would likely delay the next glacial cycle by at least 100,000 years. We have, for now, cancelled the next ice age. But there were times when the planet went even further, when ice didn't just cover continents, but the entire globe. Around 700 million years ago, during the Cryogenian period, Earth may have become a snowball Earth. Ice stretched from pole to pole. Oceans were sealed beneath frozen caps. Even near the equator, temperatures may have dropped below freezing. Life nearly vanished. But volcanic activity slowly released carbon dioxide into the atmosphere, trapping enough heat to thaw the world again. Without that global reset, complex life, and eventually, us, might never have existed. Today, we're living in the opposite extreme. Instead of a planet drifting toward cold, we're pushing it toward heat. Since the dawn of industry, global temperatures have risen by over 1.2 degrees Celsius. It doesn't sound like much, until you realize that just 4 degrees Celsius separates today's world from the peak of the last ice age. That small shift transformed the planet. And we're now moving just as fast, but in the other direction. The glaciers that have survived for millions of years are melting. Sea levels are rising. If nothing changes, the warmth we create today could outlast our species, reshaping Earth for hundreds of thousands of years. Ice ages are part of Earth's heartbeat, slow, powerful, inevitable. We may delay them. We may even erase one cycle entirely. But over millions of years, the planet will find its balance again. Long after our cities crumble, long after our machines fall silent, the ice will return, as it always has. Mountains will grind beneath glaciers. Oceans will fall. And a new world will emerge from the cold. Because in the story of Earth, warmth and ice are just chapters, and we are living in a brief, fragile page between them.